Hello and welcome to the 2017 CIO virtual event, Unlocking the Power of IoT. My name is Deanna Caldera with Argyle, and it's great to have everyone joining us today. I have a few administrative details to share with you, and then I will turn things over to our esteemed speakers. First, we would like to thank Nutanix for their partnership with today's event. They've been a wonderful thought leadership partner to Argyle and are committed to providing you with valuable content and a great overall experience. So thank you again to Nutanix. We appreciate you joining us today. We welcome you to stay connected during today's event. For those who are active tweeters, please use the hashtag CIOwebinar. You could also follow us on Twitter, Argyle Forum, Exec Forum, and be sure to join our LinkedIn group, CIO CISO Forum. I also want to take a moment to touch on our content neutrality policy, which we've curated based on the feedback we've received over the years from our members. Argyle is very proud and protective of this policy, as it reflects our commitment to ensure the neutrality and overall value of the content presented at our events. We've worked closely with our speaking faculty to ensure that you receive a set of balanced and neutral viewpoints during the session today, and we appreciate our members' support of this policy. We will send a brief feedback survey to you following the event, and we greatly appreciate your feedback, as it helps us make sure we are always providing to improve your experience. If you have any immediate feedback, please don't hesitate to reach us at feedback@argyleforum.com. We have a sampling of our upcoming CIO leadership forums that may be of interest to you. We'll be in Chicago next week on September 12th, New York and Toronto later this month. We'll also be in San Francisco on October 26th, and we'll be in Boston and Atlanta in December. So if you're in the area, we would love to have you join us. Finally, and most importantly, please submit any and all questions that come up during today's event into the Q&A section of the interface. Following the panel discussion, we have set aside time for our speakers to weigh in on these questions. Without further ado, I would like to introduce Satyam Vaghani, Vice President of Technology at Nutanix. We are pleased to have Satyam with us to deliver opening remarks. Welcome, Satyam. Over to you.
Thanks very much, Deanna, and thanks a lot to the audience for making the time to attend today, and to the panel for sure. We have a great set of folks on the panel, from people who are creators of technology to people who are consumers of technology in the healthcare vertical, in the finance vertical, in airlines, transportation, etc. So, more than anything else, I'm really excited about the discussion we might have after my opening remarks. I just want to spend the next few minutes kind of framing what IoT is and potentially, the big problems that exist in this space that might need very elegant solutions for IoT to become mainstream. And before I go there, just an obvious reminder that most of my remarks are about future-looking technology, and it doesn't represent any commitment from at least my employer, Nutanix, in terms of product delivery or timelines. Now that said, at least when it comes to IoT, it began as a personal journey for me. My company was acquired by Nutanix last year, and when I came in, my biggest challenge was to figure out how to help get the company into a leadership position in a space that potentially doesn't exist right now. And to figure out what that space could be, I started following the breadcrumbs. And so here's one way to follow the breadcrumbs is, here's a chart to show the amount of compute that's deployed in various form factors around the world. There's a whole bunch of computers that are running in the public cloud. Between the top three providers, we estimate there's roughly 3.5 million computers that make up infrastructure as a service and platform as a service. And that's 1/10 the amount of computers that run in the private cloud. Yet, we are incredibly excited about what the public cloud can potentially become just because of the potential and the fact that at the end of the day, it's a very disruptive platform compared to where we were. It's a very disruptive platform in the way we consume computing, but it's also a very disruptive platform in the sense of the potential services that might come out of it, which might be very different from the services that came out of the private cloud, for example. And that in itself represents a fundamental change in compute paradigm. Every time there is a fundamental change in compute paradigm, I think there is the potential to create a new technology space that didn't exist before. We saw this in the smartphone space a few years ago when the first smartphone was created, the iPhone. It was a fundamental change in compute paradigm because the operating systems for the smartphones operated in a very different way than the operating systems that we were used to on desktops and servers. And so I think the world of machines is that next fundamental change in compute paradigm, and that is the reason why I'm really excited personally about IoT, is every time there is a fundamental change in compute paradigm, there is an opportunity to create a new operating system and a new operating experience around that. And what I mean by that is, if you look at when we went from desktops to cell phones, mobile phones, smartphones, we saw that the operating systems that we created for desktops didn't quite work for smartphones. We had to rethink the problem because the experience that humans were expecting to derive out of smartphones was very different from the experience that they derived out of desktops. The use cases were almost the same. It was about sending emails, maybe, looking up your calendar, hooking up with buddies on LinkedIn and so on and so forth. But the haptic experience was fundamentally different. And hence we had to rethink what an operating system should provide as core services. It was no longer about whether an OS can do a file system or a networking stack or any such thing. It was more about whether an OS can do one-click applications, whether an OS can provide applications that auto-update themselves, whether an operating system can provide notifications that are outside of the control of applications. So applications don't get to create pop-ups. Instead, there's a framework to create notifications. So that was the change in how we thought about the experience going from desktops to smartphones. We've seen the same thing happen in data centers. Is when we first created the private cloud, we saw the rise of hypervisors because it was no longer necessary for a single operating system, like in the desktop world, to run on a server. It was important to partition a very beefy server into what looked like many, many logical different operating systems that led to the rise of virtualization, various vendors around virtualization and so on. But then, same concept, when people tried to apply it to the public cloud, it led to the creation of yet another operating system, which was not just about virtualization, but it was also about providing services that make virtual machines invisible from the point of the end user. It was no longer about deploying database virtual machines anymore. It was about just consuming database as a service or email as a service and so on and so forth. So fundamental changes in compute paradigm, and that always leads to a fundamental change in the operating system, the thinking about the user experience around that compute paradigm. And so all in all, I think the world of things, the world of machines, is that new fundamental change. It's not only about the fact that there are 3.5 billion machines already powering enterprise IoT applications, but it's also the fact that those machines don't need email as core services. They don't need a file system as core services. They don't need LinkedIn as core services. They need something fundamentally different. They need to consume data as fast as they can and draw interesting insights out of that data as fast as they can. And so that's the new potential service that is going to be relevant in the world of machines. And to me, that's very exciting because that's a new operating systems problem. It's an OS that is unlike any other we have created in the past. And it's not an OS in the sense of traditional operating systems. It's not an OS that's a little ISO image that you install on a PC or a specific piece of hardware. The OS in this context actually spans multiple rings of a universe, right? The outermost ring of a universe is a whole bunch of sensors. These can be very tiny devices, HVAC sensors, temperature sensors, radars, lidars, webcams, etc., etc. They all collect interesting data about the real world. In other words, they digitize the real world for the machines to make sense out of. And all that digitized information is relayed to what's called the edge. It could be a smart factory, it could be an airport, it could be an oil rig, it could be a hospital, a retail store, forward operating base, an aircraft carrier, something that is not the traditional data center, something that is far away from traditional data centers, in fact. And all those edges could then be connected to a cloud, and this could be a public or private cloud, it doesn't matter, but that's potentially the final place for some amount of that real world data to be archived. And so when I talk about an IoT operating system, an OS for the world of machines, I'm essentially talking about an OS that spans all these three rings of the universe, an OS that makes data and code movement seamless between all these entities, all the way from the sensors to the edge to the cloud. And this is the opportunity for providers of technology to create and for consumers of technology to adopt. And this is not an opportunity where consumers of technology are going to be silent, because every use case, whether it's an airport or a retail store or a aircraft carrier, the use cases are so massively different that this is not a case where we are going to be able to make an operating system in the Silicon Valley in isolation and then go out to consumers and say, hey, would you like to have it? This is going to be a great chance for consumers and creators of technology to work together for change right from the design phase. And that gets me really excited. Now, there is one big difference in how we create this technology compared to where we already are, which is the world of private clouds and public clouds. Is the one big realization that at least I have personally come to is, and this is some data from a different vendor, Cisco. They published this global cloud index where they quantify the amount of data that crosses the private and public clouds of the world combined. In the year 2017, they estimate roughly 8.5 zettabytes. That, a zettabyte is a billion petabytes. 8.5 zettabytes of data to cross public and private clouds. And this includes everything, all the public cloud providers, all the public websites, the YouTubes of the world and the Gmails of the world, to everything that goes on inside private data centers, whether it's a bank or the government or whatever it is. 8.5 zettabytes. By the year 2020, it's going to roughly double to 15 zettabytes. Hard to read here. Just this year, the world of machines is going to produce 32 times more data than the public and private clouds will ever see. And by 2020, the world of machines is going to produce 40 times more data than the public and private cloud will ever see. And so this raises an interesting question, as we, as technologists, have probably gotten to a point where we have almost perfected the public and private cloud. And now we wake up to this possibility that everything that we have worked towards potentially holds not even 1/10 of the amount of data that the world is going to produce in 3 years from now. And so that's an interesting dilemma. It's also an interesting opportunity. It's an opportunity to create a new operating system that can handle 40 times more data than some of the cloud operating systems that we've already created. And to me, again, it's very exciting because the current cloud operating systems, whether it's a private cloud or the public cloud, are already very magnificent and sophisticated. So imagine the sophistication, the impact, the importance of an operating system that can handle 40 times the volume of data that our current generation can handle. That's an exciting proposition, at least for me. And the question is, why is all this data that's generated on the edge not coming to the cloud? And the answer is very simple, is, in various use cases that you see, whether it's smart cities, smart retail, smart airports, there's clear quantification that a lot of this data needs to be cleaned, and hence, that just the cleaning needs to be taken care of. at the edge before it hits the cloud, because otherwise we are just going to create a very inefficient system. So one reason the edge sees more data is because it just processes it right there. The other reason is latency. It is posited that a lot of decisions need to be taken at the edge. And those decisions, all the data that needs to be used for that decision making doesn't need to make it to the cloud in the first place. And the Tesla is a good example. The smart car, a self-driving car, if you will, doesn't need to relay all the radar data to the cloud to figure out whether it's going to get into a crash or not. It needs to make all those decisions right there on the car itself, which is the edge, if you will. And then the cloud, in this example, would essentially focus on the long-term aspect of how the Tesla's brain evolves to drive better. And that is done by aggregating a lot of data from all the Teslas around the world, but only anomalies, all the things that they are not yet programmed to react to. All the anomalies make it to the cloud, and the cloud can essentially train a better model for a self-driving car. So real-time decision-making on the edge, long-term decision-making on the cloud, that's the model that we are all waking up to, and which is why a lot of the data doesn't leave the edge for the cloud. And so in terms of technology impact, what the bar chart that I just showed you means is we are potentially, in terms of IoT technology and edge computing, we are potentially going to change from this model today where we essentially have a lot of sensors collect data and shove that data as fast as we can to the cloud so that we can run real-time processing in the cloud and then some long-term processing in the cloud. We're going to move from that model to this new model where we are potentially going to deploy a reasonable amount of computing on the edge. And this is going to be non-trivial devices because these devices will do analytics, they'll partly do machine learning and so on. And so these non-trivial devices will be capable of crunching through data to take real-time decisions. And then only a subset of the data makes it to the cloud for long-term processing. And so the world of IoT gateways will eventually give way, in my opinion, to edge computing, a world of much more capable devices that are deployed outside of traditional data centers, outside of the traditional public and private cloud domain, that are capable of taking very real decisions based on data coming in from sensors. And so in that world, now suddenly we have a new dilemma, is that we as technologists have already proven ourselves to be very incapable of doing distributed computing at scale. And it's a very hard problem because it's a distributed systems problem, it's a security nightmare, it's a data distribution nightmare. And now we are going to face this world where almost every application in the world of machines is going to be a distributed application. It's going to be spread between the cloud and the edge. And so then the question is, can we as the industry provide a platform solution to this massively distributed problem? Can we make it much easier to create applications that are distributed? And so the question is, well, what makes it hard to create applications that span the edge in the cloud? And here's some examples of what makes it hard. Is, we're hardly capable of creating monolithic applications, a simple database that runs inside a VM that is sitting in a private cloud. And now we've got to create applications that use analytics as first-class functions, applications that use machine learning as first-class functions. And by the way, we've got to secure that application, part of which that runs on the edge, part of which runs in the cloud. And we've got to use cutting-edge technologies. We no longer have to just use VMs or some such thing. We now have to figure out how to use high-level frameworks, things like, say, TensorFlow for machine learning, or OpenCV, or Keras for machine learning, or things like Spark for analytics, or Beam for analytics, and so on. So the question is, how can we make it such that a simple technologist that doesn't have 2 degrees in computer science can deal with the unbelievably complicated math of analytics or machine learning? How can we make it such that most of these services are now provided in a much simpler to understand way than what they are today, which is, it requires real data scientists to make any sense out of data. And, if we are not able to reduce the barrier to entry, the technology barrier to writing interesting IoT applications, then I posit that we won't have interesting IoT applications. And if we don't have interesting IoT applications, then IoT will fail as a technology. People will lose interest. And just to kind of make the problem real, I have an example before we open it up to the panel. And here's a smart airport example. There's a bunch of sensors on the airport. There's a bunch of webcams at every airport. Let's say 2,000 of these spread across the airport. A few HVAC sensors, a whole bunch of kiosks where people print out boarding passes. And all of these devices are sources of data that digitize the airport, that feed into potentially a bunch of devices that constitute the edge at the airport itself. And a whole bunch of these edges, a whole bunch of these airports are connected to the cloud. And in this context, if we were to create a simple application, an application that can potentially detect a person of interest or an object of interest, like let's say a white van or a red car or a terrorist, to create a simple application to detect that person, we would have to train a machine model on the cloud to detect that object or person. We've got to deploy that model to the edge. We've got to figure out how that model runs on the edge, whether it's a VM, whether it's a container. We've got to figure out how to package that model in that runtime. How do you package that model in a VM or in a container and so on? And how do you do persistence on the edge? How do you store data on the edge? What is that service? And how do you make it such that that data can then make it seamlessly to the cloud? How do you write the logic to move that data from the edge to the cloud? How do you secure that data movement from the edge to the cloud? How do you optimize the data movement from the edge to the cloud? What is the persistence layer for that data on the cloud? Are you going to use a time series database? Are you going to use some kind of object store? And so on and so forth. There are so many decisions to make, and most of these decisions have nothing to do with the core application logic that the person was out to create in the first place, which is to detect an object or a person and raise a flag. The application, the business logic was as simple as that, but to enable that business logic, you got to create all these, various steps, various technology pieces that are very difficult to create. And so in our opinion, in my opinion, it'd be very interesting if we can create an IoT operating system which does two things very well. Is number one, if it can provide data services that are much more cloud oriented, and those data services, if it can provide those data services on the edge. And so I guess what I'm talking about is if we can create a micro pass on the edge, just like the pass layer that we have on the cloud, so that we can potentially provide unstructured data as a service or streaming data as a service. So all the data coming in from the sensor can be stored on the edge without the application having to worry about how to store the data, without the application having to worry about how to actually run and operate and manage and update and secure a streaming data service, or an unstructured data service, or a structured data service for that matter. If the platform can provide it, it becomes all the more easier for the IoT application writer to just consume that data service, whether it's on the edge or the cloud. In other words, essentially providing a cloud-like experience on the edge. Similarly, on the application services side, if we can make it much easier for developers to literally deploy code to the edge in a serverless fashion, just like how they deploy code to the cloud, then the experience creating applications is very similar to the experience creating applications on the cloud. It's a very homogeneous experience. And last but not the least, if we can make the seams between the edge and the cloud go away, if we can make it such that people don't have to worry about moving data between the edge and the cloud as application logic, if they don't have to worry about moving data between securing the network between the edge and the cloud as part of application logic, if they don't have to worry about optimizing the network connectivity between the edge and the cloud as part of application logic, I posit it will be much, much easier to create IoT applications that are massively useful. And so that's the IoT operating system that we envision, is something that converges the edge and the cloud into what looks like one seamless piece of infrastructure. And if we can do that, we will severely reduce the infrastructure burden for edge computing and for IoT. And we will obviously reduce the development burden, because now this is a much more developer-friendly world for edge computing than infrastructure-friendly world for edge computing. And with that, I'll take a pause, maybe invite Diane to bring in our panelists, and we'll start our panel discussion.
Perfect. Thank you, Satyam, for that great presentation. Just as a reminder to all of our listeners, please submit any questions that you have in the Q&A interface. And following the panel discussion, we have set time aside for our speakers to weigh in on these questions. So now we're going to kick off the panel portion of the event. We have an excellent panel lineup today. So I'm just going to allow each of the panelists to introduce themselves. So Anthony.
Yeah, hello everybody. My name's Anthony Maiello. I work for a company called Sabre Holdings. We're a travel, airline, hotels, travel agency company. And I am the Senior Vice President and Chief Technologist for software development. Thank you.
Perfect. Thank you, Anthony. Chris?
Hey, everybody. My name is Chris Matthieu. I'm one of the original co-founders of the OctaBlue IoT platform, which was acquired by Citrix a couple of years ago. So now I'm the Director of IoT Engineering for Citrix.
Perfect. Thanks, Chris. And Kumar?
Hi everyone, Kumar Srivastava. I started my career at Microsoft. I've been in technology for a lot of years. Most recently at Bank of New York Mellon's Innovation Center in Silicon Valley.
Perfect. Thanks, Kumar. And last but not least, Christine.
Hi everybody. Good afternoon. My name is Christine Watts, and I am the Chief Enterprise Architect at the University of Chicago Medicine.
Perfect. Welcome, everybody. So today's panel will be moderated by Satyam. So Satyam, over to you.
Thanks very much, Deanna, and thanks a lot again, Anthony, Chris, Christine, Kumar, for joining. I guess maybe we'll kick it off by maybe understanding a few IoT use cases, or edge computing use cases for that matter, that you guys might have encountered in your own jobs. Would you, maybe Christine, Anthony, Kumar, would you guys maybe mind starting off talking about potential edge computing and IoT use cases in healthcare, banking, transportation, logistics, etc.?
Yeah, certainly. I'll go ahead and get us kicked off. So ultimately all of us have some experience with healthcare. I think most people can understand what it feels like to go into a doctor's office, interact with the healthcare providers, or potentially have experience with either yourself or a family member being admitted into a hospital, and seeing all of the devices, that are around, just connecting everything. And from an Internet of Things, right? You think about all of those devices as Satyam was describing earlier. They're synonymous with all of the edge devices he described. They're all streaming information. And in our environment, some of the examples would be the monitors that are connected to patients as they're admitted, in a hospital setting, that are taking your blood pressure and monitoring your temperature and other, respiratory rates and, all kinds of things. All of that information is flowing through our ecosystem. At the same token, we have a lot of other information, even our hand sanitizer devices in the patient's room or just outside of the patient rooms are actually connected. We can sense when somebody is using either the soap dispenser or the hand sanitizer dispenser. We also have other devices, that are sensory type devices that can determine when somebody is walking in and out of a room, or just no different than a light sensor. When you walk into a room, we'll turn a light on. And all of that information we're actually capturing and have the ability to marry that up with other information that we're storing in our medical record system, our core system, and then can perform those analytics on it. So I think we have a lot of examples where we've successfully been able to develop and test those types of predictive analytics on information, that's static information, sometimes changing in your medical record, but then the streaming data that's coming out of devices, those edge devices, and other sensory devices, and then drive near real-time, it's not exactly real-time, but near real-time decision at the point of care. And a really good example of that is a solution that was developed by one of our researchers here at University of Chicago. She's also a physician. She developed an algorithm based on quite a bit of retrospective information that can predict when somebody is likely to go into cardiac arrest within a period of time. That algorithm ultimately generates a score, and then we automatically alert a set of nurses to go check on a person if that score is within a particular range. There's a number of different factors that can influence that score. Again, respiratory rate, lab values coming back from lab results that patient may have had done. And all of that is ultimately driving changes in our workflow for our providers, but it's also directly impacting our ability to deliver really good care to the patients. And in some cases, we're preventing that cardiac arrest from happening at all. We're not quite ready to say that it's saving that person's life, but I think that over time, one of the things we are seeing is it is impacting mortality. The more people that we can prevent a cardiac arrest, the more people that are actually surviving whatever illness has got them here in the hospital.
That's fascinating. It looks like next time I don't use a hand sanitizer, it's going to judge me.
We actually use that use case to track, use of the hand sanitizers by our staff going in and out of rooms, because that's one of the things that we do know is clean hands actually helps prevent the spread of disease. And in a hospital, if you think about things like MRSA, not sanitizing your hands as you're going into a room and then coming out of the room is actually a key factor in the spread of something like that across the hospital or just a unit within a hospital. And so, we use that to track our own adherence to the rules, to make sure that you're sanitizing going in and out.
Makes sense. We always have, when it comes to the world of machines, we've always had a fascination about when Skynet is going to come alive. But, the more I hear about examples like this, I think the world of machines is going to kill us, not by literally killing us like Skynet, but by, becoming our mommies, reminding us to use the hand sanitizer, etc. But anyway, with that, Anthony or Kumar, would you guys like to add, interesting use cases from your own verticals?
This is Anthony. I'll go first. Travel industry. Everybody buys airline tickets, takes flights, fly on business, leisure flights, trips, those kinds of things. Everybody kind of understands what we're dealing with here. This travel industry that we all use and love every day, nobody pretty much goes to an office anymore and orders tickets from a travel agent and gets those paper tickets and utilizes them that way. So today it's much more demanding. All of us are pretty used to going online and clicking a few clicks on your mouse and getting some electronic tickets. Well, that was then, and as we move into today and the Internet of Things and the industry's become more and more demanding. The expectations from your typical traveler is pretty much through the roof. Travelers are expecting great traveler experience, and they deserve that. So from shopping for tickets or shopping for hotels to reservations to the actual ticketing to ancillary services, check-in and more, this is the whole travel process and travel experience. And then there's also some behind-the-scenes work that's being done from the airlines and the hotels themselves when it comes to operations of their own aircraft, such as fuel consumption, utilities, flight plans. Those kinds of things are also part of the equation here. So we're always under constant pressure to provide better service and keep it at a low price. Our industry is not a commodity, but it's priced very competitively. So as you provide more services and more capabilities, you have to keep the price where it is. So the bottom line, we are using technology, as you heard earlier, pretty consistently. We're using technology to integrate data. We've got many different sources where we collect this data from people, individual profiles. Everybody has a profile or set up with an airline where you get loyalty programs and points and things like that. These are all typical areas we collect the data from. But the bottom line is we're trying to enhance the personal individual experience for the traveler themselves. So they expect more smarts. They trust their technology is very dependable and it's always going to work. So, for example, some of the areas where it's very different than just getting airline tickets and going on an aircraft and then you're finished with your flight. We look at all sorts of equations from pre-reservation before you book your tickets to post-reservation after you book your tickets to even during your trip. There's opportunities in in-flight experience and things like that, and then also post-trip. After you're finished, what kind of services and experiences can we provide at that point as well? So we look at those 4 different scenarios. And for example, navigation will become a lot easier. We'll know if you're sitting at an airport and your connection flight is starting to experience flight delays, whether it be due to weather, potential weather, or potential machine. The aircraft itself might potentially have some equipment failure that we're monitoring as well, where equipment could be failing, and we're alerting the airport that could be happening. So all these things could be working into the equation. We could advise at that point, here's multiple options right on your mobile device that you may be experiencing a delay in your flight. Here's some other options for you to take, and if you take those options, we can also change the reservation at your hotel and also your dinner reservations, and we could also automatically call people that you may be meeting at your destination. And do all this because we know who you are, we know the meetings that you've set up, we know the arrangements that you've made, we know your profile, we know your loyalty programs, how many points you might have, and things like that. So we can make that a whole lot easier when it comes to disruptions during your trip. When it comes to check-in, things that we've done even today, there are experiments, and you heard some of this with the smart airports. We've done some work where instead of going to check-in counters with your ticket to check yourself in, you're automatically checked in as you walk through the airport, either through facial recognition, through some sort of retinal recognition, or even easier than that, just GPS position of where your smart device is and things like that. And so we could automate check-in. We could track your baggage, not just with a number that potentially it's landing at a certain airport, but it actually will position where your bags are right now at any point in flight. And even during your in-flight experience, we can personalize your experience much better than what we do today. Today, you can say, hey, I prefer a vegetarian dish while I'm sitting in first class or business class. We can go a little further than that because we know everything you've ordered in the past, everything you've done in the past. We can now assume and make recommendations on the different types of things that you could do on the aircraft or in the hotel for that matter, and so forth. And to make things even more mind-blowing here, there's some conceptual models that we're looking at now that actually add more sensors to the aircraft where we can detect what your anxiety level is on that plane. If you're flying and your body temperature is a little hot, or you could test your hydration levels and things like that, we can detect that. We've run some experiments doing this where now we can make sure that if something like that is detected where you need water or you need your body temperature is going up, your anxiety is going up, we can have a flight attendant take care of you in different ways and make it really personalized so that you're more comfortable and you have a better traveler experience. And things like that. So the list is endless here. I can go on and on and on about this. It's pretty fascinating when you look at the potential. Really, the only limitation we have here, just like most applications, is our imagination on what we can do. So it's a pretty cool field to be in right now.
See, that's very well said. The limit is our imagination, and in fact, I'll probably ask Chris later about how we can make it such that we can reach our imagination, the limits of our imagination faster with analytics, machine learning, etc. But anyway, before I go there, Kumar, any final thoughts from your side in terms of use cases?
Sure, yeah, of course. So, investment and financial services is interesting. It has the application of IoT. So there are devices that people own. There are systems that they log into. So, in terms of physical sensors, there's not that much prevalence of these sensors. But what we do have is the need to detect changes in behavior, changes in intent, and generate the signals that trigger certain actions from our employees, from our users, from end users, or from intermediaries like investment managers. So so what I mean is, typically in an investment flow in that process, it's a 4 or 5 stage process. That the stage where the user or a consumer, individual user, or an institutional investor realizes that they want to do something. They want to do a transaction, buy, sell, move money around. It could be anything. The second stage typically is that they look for someone to advise them on how to and what to do. What should be their investment strategy, and to do that they have to find a particular advisor. Now, the advisor could be a system, could be a software service, it could be a person, it could be an institution. But there's a discovery process of finding someone and making a decision to, use somebody's advice. From that stage, then you define your own strategy of what you want to do with the help from this advisor, and then you start making transactions, making decisions, which then lead to transactions happening and being processed by financial institutions, and then they have to be reported upon, analyzed, and there's a feedback loop that leads to changes in the investment strategy, changes in the risk profile or the exposure, or whatever the decision might be. So this is, there's a cycle, and every stage in this process, there are different systems being used, different applications, different processes, different pieces of information that have to be combined together to help someone devise a strategy, to help someone pick an advisor, to help someone adapt and react to the transactions, to the impact of their strategy that they've seen. And so what we're really talking about is, the strategy of taking everything, as Satyam said, taking everything back to the big cloud and running it through batch processes to produce an output that says, 3 days or 2 days or a week later, that somebody should have done X, that doesn't cut it anymore. So we need our employees or the investment managers who are intermediaries or proxies to consumers or institutional investors to have the latest information, and not just at the raw level, but also at the process level, where where is someone, where is an end user, and what stage in the process are they, what are they trying to do, what is their intent. So that information is processed in near real time and then presented back as an opportunity for someone in the supply chain, the value chain, to add value. And so you need to be able to process this information, many different signals coming from all over the place in near real time, and then generate the recommendations or the insights that someone in that value chain needs to add value to the ultimate user, the end user, or the consumer, or the institutional investor. And at the same time, all this information can also be leveraged in real time through the application of machine learning and AI to predict if a customer wants X and X is not likely to happen for whatever reason, what can be done. So how can the organization react faster to understanding that things will not go as planned? What is the expected impact on the customer, and what is the expected impact on the organization, and then react to it in real time to address that. So it could be reducing, on the positive side, you end up making the market more efficient by understanding these signals from all over the place. But on the micro level, you make the organization more agile by being able to ensure that its employees have the best possible information to service the customers, that you can predict, based on the actions of the customers and where they are and what they're doing and what they need to do. Are there going to be any potential areas of dissatisfaction, and what can who and what can that person or that team do to prevent that? So it really comes down to taking these decisions from happening in the center of the organization to the edge, and then connecting the signals directly in these IoT applications of sorts to So say if my job is customer relationship management, I should have an application that takes in the relevant data that's coming in from outside the organization or inside, puts it together and produces the signals or the insights that I need as an employee with that specific function to perform my job at the best possible level to make sure my customers are happy. And this might be for someone else, the same data or a different subset of data might be used in a very different way for let's say an operations analyst to perform a transaction or enable a transaction. So they might use the same data, but their application, their use case is very different. So what you really need is this real-time behavior, real-time processing, but also multiple parallel processing of potentially the same data happening in many different applications at the edge to enable the use case of the intended user.
Exactly. And so, in fact, that is a common theme between what all the three of you said, right? IoT is not just about consuming a ton of data, but it's also about democratizing access to insights out of that data. So you think about that nurse, his or her use case out of, the exact insight they want to derive out of data is very specific to their job. Or you think about the flight attendant, the exact insight that's interesting to them so that they can serve their customers better is very kind of special to their job. And then, like you said, an investment manager might want to derive some insights, and gone are the days of having to wait for a month for your mainframe to tell you what you should do for a particular client. Those days are gone. So I guess that leads me to the segue to Chris, is, it's not just about collecting data. I've seen that, in the IoT use case, many kind of, architectures, the architecture skewed towards how do you make data collection very easy. But the problem is then, you are sitting on a bunch of data. Different people have different needs out of that data, which require different analytics programs to be written or different machine learning programs to be written, etc. And that too, partly on the edge because of all the latency, etc. reasons we talked about. From your experience, Chris, how do you make that tractable? How do you make it such that it's much, much more easy to do analytics or machine learning on top of raw data than it is today? today it requires data scientists. Is there light at the end of the tunnel?
Yeah, that's a great question, and I think it ties in nicely with what you kind of teed up about, the importance of the edge, the massive amounts of data that is coming. It's coming at us pretty quickly. The cloud platforms were really mostly designed for downloading, data. I'm thinking like Netflix or YouTube videos, et cetera, not necessarily uploading or streaming massive amounts of real-time data to the cloud. So the need to have edge networks better connected, better computational capabilities is important. We started off with trying to connect all of the things together. And, these things talk different protocols. They have different data schemas, even temperatures, for instance. Not every temperature sensor chirps data the same way. So there's a lot of this learning that we went through, just connecting disparate things together on the edge. And then you have to think about, okay, now that you've done that, now we've got to start looping people into these messages or the connectivity of these systems. And a lot of these vertical use cases talked about that. Also, systems is another key piece, like the emergency medical record systems or flight systems, along with all of this sensor data. Once you have all of these things connected, a lot of us are going through these phases of automating things. So we're saying, hey, when this temperature reaches this threshold, or this patient temperature reaches, this vital reaches this threshold, then start doing things, start alerting other nurses or doctors that there might be a cardiac arrest situation. So as we automate, we also analyze that data. And that data, because there's so much of it streaming so quickly, we do have to get into the practice of analyzing that data on the edge where possible, and then streaming really only what's important up to the cloud so that we can do heavier machine learning training, et cetera, in the cloud where we have more compute capacity. And then what Kumar was talking about predicting, the closer we can drive that machine learning or that artificial intelligence to the edge, the faster the response times will be at predicting what's happening. A great use case for that is the driverless vehicles. I sit near the Arizona State University campus, and I'm watching Uber and Google Waymo and GM cars, all three vendors' cars lapping the campus every day. And these cars are like mobile data centers. They've got all of these sensors, all of this compute on four wheels, and they're making these predictions in real time. Someone steps into the road, what should I do? How should I swerve? Can I stop? We have got to get to this point where this is the new norm. I think that, to your point about blurring the lines between the edge and the cloud is already happening, and that needs to happen for this type of new normal to be successful. And I think we're quickly reaching a point where pretty soon everything will compute. Not only edge gateway servers or cloud, but wherever you have spare capacity everywhere, it should be candidates for computing to get us to the point where we can make real-time decisions based on real-time machine learning, real-time analytics of data, and as we see anomalies, being able to react and further improve our automation.
Makes sense. Personally, I go through these waves of extreme optimism to extreme pessimism. Given the scope of the problem we are out to solve, it's going to take a Herculean effort. But if we can do it, I think this is going to be worth writing books about. So I'm very excited about that. Folks, just in the interest of time, I see we have roughly 5 or 6 minutes now. So maybe lightning round now for all you guys. Switching to the human side of IoT and edge computing, we are talking about creating technology that isn't being taught for in schools. or in previous jobs that people had. How are you guys, getting talent or honing talent to deal with this new generation of applications, new infrastructure that people have no experience on? Any interesting insights there?
Ms. Christine, I think that's actually a kind of a tough one, but one thing I would suggest in trying to stick with the vendor neutral, policy, we've been lucky that we have found, a few vendors, and I will not name them. If you're interested, you can reach out to me separately, where we're able to get brand new talent, with 1 to 5 years experience. And then, as you say, we're able to bring them in. They're young, they're energetic, they are just like sponges and want to learn. They're not afraid to fail. And so we've been able to take, a few people like that and really mold them into the type of resource that we need. And it might be a developer resource or it might be an analytical resource. But I do think leveraging sourcing partners that can find that type of young, energetic, new, fairly inexperienced talent is one thing that we personally at UCM have found some success, specifically in the technology space. And that would include partnering with various intern, organizations where we can get interns as well.
Makes sense.
Yeah, I've seen something similar on my side. I think the focus needs to be on the application development part with minimal time and effort, as required, being spent on the infrastructure and platform layer. And I think what that leads to is when you keep your focus and eyes on enabling the actual problem, or solving the problem that you have, and through custom built application, then that teaches the teams or individuals to make decisions that are optimized for the application, which means that finding so how do you pick the best vendor, or how do you pick the best open source technology, or whatever, anything in the middle that gets you closer to the output, or the output that you are trying to enable. And by keeping your eyes and through, from a product perspective, from making sure that the user's requirements or the use case is top of mind, that leads to cultivating that discipline and that culture of, the app development as opposed to platform and infrastructure, which should be, influenced by the needs of the application as opposed to the other way around. And so I think we're just, because of this focus through ML, AI, IoT, we're actually entering this phase where application development becomes extremely critical. And we're leaving the phase where, the last few years, the focus has been on platforms and infrastructure, especially with cloud and becoming bigger, and mobile devices causing the platforms to grow and mature. But now I think the focus really has to come to intelligent applications that leverage the platform's infrastructure. And then you pick the infrastructure and app platform depending on the needs of the app, as opposed to the other way around.
Very true. It's becoming an application-centric world. And in fact, a lot of infrastructure guys are now moving to thinking application first. So good observation. Looks like we are just about out of time. Any final comments you guys would, anything you guys would like to share before we have a few questions on the line, and before we switch on to the questions?
I think the one thing.
Go ahead.
Go ahead. So I just real briefly, I think one of the things, and you touched on it a little bit, but we're definitely starting to see this in healthcare as we are evolving our cloud model, right? We have many different applications and capabilities that are deployed, software as a service, infrastructure as a service, and they're leveraging various different cloud platforms. As we look to, and I think you had a comment in there that said it's an extended data center strategy. I think that's a great way to describe it. We all know that one cloud solution is not going to be sufficient. right? And so I would argue anybody who's trying to get you to focus on pick a cloud vendor and stick with it is probably heading you down a path that's not appropriate. So think about, again, using that term, the extended data center strategy. I'm going to have to borrow that from you. But then what we're describing, our cloud strategy, is a dynamic hybrid cloud, because we also realize that eventually even cloud compute is going to become commodity, right? It's going to change in price minute by minute, day by day. And as you're starting to develop and think about where you want to deploy your capabilities, right, whether it be in a on-premise data center, a colo data center, that extended data center strategy again, or onto a cloud platform, whether it be private or public, also think about what you need as your base capabilities, again, part of that operating system or that operating model that's going to allow you to flex, right, dynamically between any of them at any time for any reason.
Makes sense,
so,
yeah.
Yeah.
Very true, very true. I think it's time for, thanks for noticing the extended data center, by the way. I forgot to mention it. But I think it's time to create a new hypervisor, a hypervisor that stretches across clouds. And this is not a hypervisor that provides virtual machines. It's a hypervisor that provides data as a first-class service. And then, the ability to write literally code on top of that data. But anyway, any other observations, folks?
Yeah, well, I knew we were running out of time, so I think one of the things, even breaking out of my travel industry for a second, I come for many years of industrial side of things with GE and other companies like that on smart grid and different things. And one thing I noticed there is that this technology has really made a big impact in industrial applications. What I'm talking about are big machines and big, what used to be dumb machines are now smart machines, and really lots and lots of data that need to be collected and so forth there. And I think when I think of the difference, how do you employ people that really understand this stuff? When I think of what we've done with the smart grid is we didn't call it edge computing at the time, but if you take the definitions of edge computing and cloud, the criteria and the education that we would use, the people we would put on these kinds of things when we had scenarios where we needed to the edge computing type of application that we're talking about here, these are things where we needed to get a lot of data, but it was a low latency situation. It was a real time. It was intermittent connectivity. It wasn't full connectivity. Things like that. And then where we played in the cloud, or more of that extended data center terminology you guys are using, this is where we had very heavy tasks, like in a sense of the smart grid. We were talking about where this is where we did all the machine learning, and we really did had the intense conversations with gas turbine engines and things like that. So I think there are very different technical approaches and very different ways of thinking about how you develop your system and the kinds of talent you need on those kinds of systems. And I think at the end of the day, putting people on these kinds of applications that really understand systems engineering and the differences on what criteria you would apply to edge computing and cloud computing, especially in that industrial scenario, plays a big role.
Makes sense. In fact, that's probably the first few success cases for edge computing. That said, I see Deanna wants to help me out with the questions. Deanna, anything you'd like to say in terms of logistics?
Yeah, thank you all for the panelists and Satyam for doing a great moderating this discussion. It's been a really excellent conversation. So we're just going to review some of the questions that were submitted by the audience throughout this entire discussion. So the first question goes over to you, Satyam. How would data and logging retention requirements be met using a shared cloud model? And kind of a sub-question to that, are there any thoughts on shared risk mitigation costs versus kind of a non-shared risk model?
A great question. I'll answer it in the, slightly in the abstract is, data retention, logging, etc. One thing is I see it as a first class, again, going back to my operating systems kind of thought. I see that that's a first class service the operating system needs to provide. In other words, the IoT application creator or the edge application creator can set some retention policy on a data stream, and then they don't need to worry about how the system adheres to that retention policy for that data stream as it exists on the edge and as it exists on the cloud, because the data stream might be severely fragmented between these two worlds, the edge and the cloud, and it should not be up to the application writer to have to deal with that amount of fragmentation. In fact, that's the only way to allow application writers to make consumption of data as dynamic as they want to, without having to worry about the cleanup aspects or the security aspects, the compliance aspects of data. So long story short, I see it as core operating system service that needs to be provided, the ability to set policies that pertain to data retention, security, mobility, whether a particular data stream should be available only on the edge or on the edge in the cloud or only in the cloud, all those things.
All right, perfect. Thanks, Satyam. So the next question is for the panel. How do you protect the IoT devices from a security perspective? So does anyone want to kind of take the lead and kind of answer this one?
Well,
I can.
Chris. Yeah, there's a few things at play here, right? I mean, platforms themselves, can ensure, encrypted or secure communications, data in transit. They can also certainly secure data at rest. There's a part of the platform that's gotten a lot of attention lately, and that's the actual devices themselves being potentially vulnerable to security issues. And my memory's going back to the Mirai bot attack that took Twitter and a lot of other sites down a few months ago. That was passwords and credentials on like video cameras not being changed. So you've got updates that need to take place on the devices themselves, security on the devices themselves. That is typically outside of the IoT platforms themselves, but there has got to be a lot more diligence, I think, on enterprise-related device selections, especially things like in the healthcare or things where life is at the hands, like driverless vehicles, healthcare systems, et cetera. Those devices need to be well protected, potentially even well firewalled themselves, in addition to having a well-secured IoT platform.
Perfect, thanks. Does anyone want to weigh in on this question as well?
This is Anthony. I can't help but help with this one too. Security. There's lots of things we worry about when it comes to this, especially as your system could be very large and very much global. Besides security, of course, you've got just the general compatibility of devices, connectivity of everything, and all that other stuff. But security has always been, at least in my industry, and I think that's true for most of ours here, is the number one concern, even before IoT. It's been a number one concern, just the fact that we're building service-oriented architectures and we've got standard ways of doing things, and things become much easier to breach and break into and things like that. So we've taken, here in my company, we've always taken that extremely seriously, and now with the IoT, it's become even more serious. And we've implemented, again, not time for long enough time for the call, but at a high level, we've implemented very new and unique approaches around how we deal with personal data from people and their credit card numbers, things like that, and so we've got different ways of dealing with encryption, data on the fly, storage. Traditional methodologies work, but we've gotten even more creative on how we secure personal data and personal data management. We continue to improve what we've called event processing in our systems here, ensuring that we've got the latest and greatest machine learning type protocols that we can protect a little easier. Again, nothing's perfect here. We continue to learn. And then I think there's general improvements to our algorithms around how we share data, how we collect data. Again, going back to the encryption, protecting data on the fly, using the latest and greatest security features around the various interoperability standards that we have. So again, nothing's perfect here, but we know IoT adds a lot more risk and security. I don't think we've quite closed that gap yet, at least not on our perspective, which is why we're cautious with the whole thing here, and really one of the biggest challenges we have, but we're getting a whole lot closer.
All right, thank you.
Makes sense.
So we just have time for one more question. So, as IT and security officers, there are challenges on how data is being protected from being compromised. So the question for the panel, and I'm going to just have Christine start it off because this person kind of wants to get the healthcare industry perspective. So how do you find the balance between processing a lot of data and being compliant to regulations concerning in on how your data is being used in the cloud? So Christine, if you want to kind of go ahead first, and kind of anyone else who wants to weigh in on this question as well.
Yeah, that's a really great question. So as part of our standard processes, we refer to it as standard work, every provider of services or capabilities goes through a security assessment, security and risk assessment, before we even implement it. And we look at all of, we look at all of those things that would be referred to as non-functional requirements, especially as it relates to security. And in some cases, we deny it, right? Or we require that people implement solutions to minimize the risk. So for example, if we're going to leverage a software as a service solution that happens to be hosted in a cloud-based environment, maybe it's, and that is a capability we're purchasing from a vendor. We may require that they do not store that highly sensitive data, or that they implement techniques to obfuscate it. So I think each case right now is being looked at individually, and in some cases, require those solutions to be deployed within our own data center if we don't feel like that they can be secured properly outside of our data center. In the future, that obviously has to change, and that's a key component as we develop that cloud strategy. I do believe that we're likely to focus more on putting compute in the cloud and keeping our storage of data in closer to the breast, as they say. So we're going to likely, whether it be on-prem or in a colo, we will not likely put highly sensitive healthcare information into a public cloud for sure, but we'll be less likely to put it into cloud than we would maybe a colo as we move forward. Hopefully that answered your question.
All right, perfect. I'm just going to squeeze in one more question here because I think this is a really great question. Kind of talks a little bit about IoT in the consumer home. So how can outside devices be cleansed when they come into the organization? So does anyone want to kind of share their perspective on this question here?
Well, most devices have like a factory reset mode that will put them back in factory reset. wiping basically all the personal settings and off of the device. That typically does not provide the latest updates to the devices, however, so you should certainly have your IT organization or whoever is in charge of rolling these devices out also update them and change the passwords on each of those devices, as well as keep some type of an inventory. As you're rolling out, thousands or hundreds of thousands of new devices, especially in the enterprise, a lot of these home automation type class devices were not designed to, have more than say 50 in a location, for instance. So you've got to take that into account, like as you start rolling out hubs and inventorying which devices are where, and maybe even which version levels they're at.
Much. Unfortunately, we're out of time. I just want to thank everyone for joining us today for this fantastic virtual event. As I mentioned, you'll receive a link to a brief survey about your experience today, and we would greatly appreciate sharing your candid feedback. You will also receive a follow-up email with the recording within 48 hours. Thanks again, everybody, and enjoy the rest of your day.